All right, guys, welcome to this page of the notes. And again, what we're doing, we'll just continue our discussion of how you evaluate logarithms using a calculator, or even if you don't have a calculator, how we can use that good old snail method to help us evaluate them even if we don't have a calculator. So again, I've got log base 3 of 81. I can't use the log button on my calculator because that is for log base 10. I don't have a log base 10. So you've got a couple of options. If you have the math print, you can just use that log base function to put it into your calculator exactly as it is. If you don't have that log base function on your calculator, you will rewrite this guy as the log base 10 of 81 divided by the log base 10 of 3. Right? So this is, right, because these are base 10 logarithms, now you can use that log button on your calculator, and if you do that, you should get 4. But what if you don't have a calculator? Well, let me show you. If I didn't have a calculator, we were doing the log base 3 of 81 is equal to x. I'm trying to figure out what is the log base 3 of 81. Well, remember, we can use the snail method. I can use the snail method to rewrite this guy as an exponential. 3 to the x power is equal to 81. And you probably wouldn't have to spend too much time figuring out that 81 is actually 3 to the 4th power. So I can rewrite this as 3x equals 3 to the 4th. And again, our properties of equality for exponential function says as long as the bases are the same, then I can set the exponents equal to each other. X is equal to 4. So even without a calculator, using the snail method and our property of equality for exponential functions or exponential equations, I get 4, which is exactly what your calculator would tell you. So there's a number of different ways to do these problems depending on the calculator you have, or even if you don't have a calculator, just using the good old trusty snail method and the property of equality for exponentials. This one, again, if you have the graphing calculator with the math print software, you can just do the log change your base, put log 1/2. I would put this, because the base is a fraction, I'd go ahead and put it in parentheses just to make sure your calculator doesn't mess up the order of operations. But you could put log base 1/2 of 256. If you don't have that, if you have the scientific calculator or your graphing calculator doesn't have that math print software, you'll just use the change of base formula, where I'm going to do a log base 10 of 256 divided by a log base 10 of 1/2. And again, if you do that, your calculator is going to give you -8. And if you didn't want to use your calculator, you could just simply use the snail method to rewrite it as an exponential and then use those properties of exponentials to solve this guy, and you would also get -8. All right, guys, hopefully that makes sense. I will ask you to several times, both in homeworks, quizzes, and tests, evaluate exponential and logarithmic functions, whether you use your calculator or some other method, in particular the snail method, to do it. It's all going to work out for you. All right, guys, so head on over to the next page of the notes, and now we'll begin looking at graphing logarithmic functions, which is our second objective. How do you graph logarithmic functions? I'll meet you guys on the next page.